All right. What is continuity? First question. Continuity and differentiability. So whenever we say it's continuity and differentiability of what? Of continuity differentiability of functions. Okay, limits of what? Limit of a function. Similarly, here also continuity and differentiability of what? Of functions. So that's the first thing. And so first we are going to discuss what is continuity. So obviously function means it will have a curve. Okay, functions means what? If you draw, then you get its curve. So now continuity. So your continuity means what? Continuity of the curve. And opposite of continuity is what? Discontinuity. If it is not continuous, then it is discontinuous. So discontinuous. So that means we are going to check mathematically if a function is continuous or discontinuous. That's what we are going to check. Okay, so now for example, so very simple, actually limits also, see that's the reason the other day we discussed, when I told limit means what? General meaning of limit only, but mathematically it's different. Mathematically, limit means what? Generally, if x is tending to 5 but not crossing 5, okay, tending to 5, it's very close. X may be 4.99999, but not 5. X is not equal to 5. So that's what I told, So when x is tending to 5, x plus 3 tends to what? This tends to 8, but it doesn't cross 8. So limit is 8. It is, you can say 7.99999, how much ever close you want, that much close you can say, but it is not 8. So it is a function. So then what we say, 8 is the limit. So that's the reason we write a limit x tends to 5, as x is tending to 5. X plus 3 tends to 8, or its limit is 8. As simple as that. Similarly, here also, that's the reason I drawn a graph the other day. I showed that as x is tending to, here x is 3, let's say, as x is tending to 3, here x is tending to 5. I wrote, okay, x is tending to 5. Here we take this may be 8. So as x is tending to 5, f of x tends to what? 8. But it doesn't cross 8. It doesn't cross 8. Maybe x is tending to 5 from left hand side, f of x tends to 8 from left hand side. As x is tending to 5 from right hand side, f of x also tends to 8 from right hand side, but it doesn't cross 8. So therefore 8 is called limit. Obviously that is the meaning. So here discontinuous and continuous also same like that only. So here, see here in this case, let's say in this case, as x is tending to 5, here x plus 3 is a curve. Let's say x plus 3, f of x equal to x plus 3 is a curve, but it's a straight curve. Okay, here, this is a, so let's say the curve is like this. Okay, let's say the curve is like this, and here is one gap. When x equal to 5, here is one gap, and then curve started like this. That means what? When we write, we have to lift up. Here you have to lift your pen, and then you have to start begin from here. Till here you came, and here gap came. So that means what? At x equal to 5, okay, f of x is discontinuous. Discontinuous. So whenever, see, now let's say this curve is going like this, and then from here it is like this. Okay, first this is f of x, total f of x is this. This is f of x only one function f of x. So here till here it came, and from then it started from here. This whole curve. This curve is what? Discontinuous. At this point it is discontinuous. At this point, let's say at x equal to 8, it is discontinuous. You are able to understand or not? Just I am showing the curve. this curve is discontinuous at x equal to a till here, till this is this curve is going and going and going, but at x equal to a, you have to lift the pin from here and you have to again start from here like this. You are able to see? You saw that?
Yes, sir.
So
Yes, sir.
continuous, but at x equal to a, I have to lift the pin from here and I have to put here, and again it is like this. That means what is x equal to a, it is discontinuous. So then where it is continuous? Continuous everywhere except at x equal to a. That means what, at x equal to a, it is discontinuous. At x equal to a, it is discontinuous, except that x equal to a, everywhere it is continuous. So yeah, so that what I'm saying is continuity general meaning is only. So continuity of what we are checking? Continuity of function. Function means what? It's a curve. Okay, if you draw, then you get some kind of curve. So that curve is continuous or not? If it is continuous, where it is continuous? If it is discontinuous, where it is discontinuous is a topic. Okay, so then we'll see continuity in detail. Continuity. Okay, continuity, we say continuity, but continuity of a function. So now first in this at a point, continuity at a point, continuity of f of x at a point x equal to a, at some point, at a point where at x equal to a. Okay, we are checking this continuity of f of x at x equal to a. So this is what we have to check. So for that continuity, one condition, you know what? Now, so we say, or we say f of x is continuous. First only I am writing continuous at x equal to a. Condition, if limit x tends to a, f of x equal to x tends to a minus, left hand limit equal to limit x tends to a plus f of x, which equal to f of a. This is what is the condition. That means, you know what? That means left hand limit equal to right hand limit, and that equal to f of a, limit value at x equal, function value at x equal to a. So when left hand limit equal to right hand limit means what? Limit exists at x equal to a. Okay, left hand limit equal to right hand limit means what? If at all limit exists at x equal to a, okay, limit exists at x equal to a. We say limit exists at x equal to a if left hand limit equal to right hand limit. Yes or no? Yes?
Yes, sir.
Yes, sir.
Limit exists. When limit exists at x equal to a, when left hand limit equal to right hand limit. So limit must exist, and that must be equal to f of a. What is f of a? Function value at x equal to a. Function value at x equal to a. You may say, so what is this? Left hand limit, right hand limit. So just yesterday we discussed that limit we have to substitute. If you substitute f of a, when you substitute, it is f of a. Obviously, it is f of a. So all the time this function is continuous. Yes, most of the times it's continuous. Some discontinuity points of discontinuity exist actually. So it looks like that. So, but the topic we are discussing means discontinuity, points of discontinuity exist. So now we'll understand this definition. So this is what is the definition. Now we'll understand this definition. So now let's take first polynomial functions, because you know here functions, we know first function we take, because you must have learned in 11th grade, you learned that first function is polynomial function. Polynomial function. What is that polynomial function? You know that f of x equal to, you know, like this, a dot x to the power of n plus a1 x to the power of n minus 1, a2 x to the power of n minus 2, so on up to an x power 0 is nth degree polynomial function. Okay, you know what n is? natural. Okay, this is what is nth degree polynomial function. This is always continuous everywhere. So of course, here at x equal to a, it's a continuity of function at x equal to a. So we say f of x is continuous at x equal to a if at all left hand limit equal right hand limit equal to function value. So second, if f of x is continuous, okay, I'm writing interval in, see, f of x is continuous in interval, I'm writing a to b. Okay. Okay, we'll write first domain. I'll write just a minute now. F of x is continuous in its domain. Domain, you know, I'll explain this. In its domain. F of x is continuous in its domain. Okay. Then f of x is called continuous function. Continuous function. So hope you understand the meaning. Continuous. So here nothing. F of x is continuous at every point. At every point in its domain. At every point in its domain. So I'll tell you what does it mean. Now I'll explain. So for example, f of x, let's take as 2x square minus 3x plus 5. You know, this is quadratic polynomial, quadratic expression you can say, or quadratic polynomial you can say. And here the domain is, what's the domain, can you tell? Domain x value, what could be x value, what x value takes? What x can take? What are the values that x can take? Domain, come on. Domain means x now. What could be x values?
Any real number, I guess.
Yes, any real number. Yes, that's true. It can be any real number. So polynomial function means its domain is any real number. Domain means what? All real numbers. So domain is all real numbers. Here you see, here this polynomial function is always continuous. Continuous everywhere. For all the elements, continuous. Why? You take just a substitution. There is no denominator, no root, nothing. So now simply you can say LHL equal to RHL equal to f of a. Always you can say this. For every point you can say this. Therefore it is continuous function. So remember, polynomial function is continuous function. So now if you would like to check, how do you check? So now at x equal to a, what is a, you know? A is any real number. So you need to you need to check every point, but every point a, I'm taking a representative point. That means what? A is any real number. Whatever real number you take also, limit extends to a minus 2x square minus 3x plus 5. Okay, this is left hand limit equal to, see here your right hand limit. Limit extends to a plus 2x square minus 3x plus 5 equal to what, you know? F of a. Here just you need to substitute f of a, right? So here let's say a equal to 2. If a equal to 2, what will happen? Left hand limit means just you left hand limit also you substitute, right hand limit also you substitute. Then f of a, how do you find this f of x? F of a also you substitute. So you get always equal. So that this will not be so meaningful, because anyway substitution, limit means substitution, we substituting. So where is discontinuous function? That is a question. So yeah, this is a simple one, but you should understand now two things: continuity of a function at a point, one thing, and continuous function, another thing. If a function is continuous everywhere in its domain, then it's continuous function. Okay, right? So this is continuous function. Now we'll go to another example. I'll show you. You may be wondering. So I'll show you another example. So where you get discontinuity, I'll tell you. Now let's say f of x is 3x. Okay. Just for your sake, let's make it simple. Somewhat simple, I'll make x plus 3. If x is, greater than 2, greater than or equal to, and x minus 1, if x is less than 2. You know what? This is example 1 here. This is defined as, see, this is what is the important thing. Here, f of x is defined two-way. Okay, this is called piecewise defined function. I don't know, hopefully. So, piecewise defined. Piecewise defined function. Piecewise defined, that means what? For this piece, that is when x is greater than or equal to, this is what is x plus 3. When x is, that means, you know what? F of 1, you know how much f of 1? 1 minus 1, 0. F of 3, what is f of 3? 3 plus 3 is 6. F of 0, f of 0 is what, 0 minus 1. X less than 2, this is the definition. X greater than 2, this is what is your function. Yes, understood this one?
Yes, sir.
Now I'll check. Here, continuity I'll check. Continuity step 1. Understand? Step 1, I am checking continuity at x equal to, at x equal to, let's take 2. I am checking at x equal to, continuity at x equal to. This is what I am checking. Okay. Continuity at x equal to. At x equal to 2, left hand limit is limit x tends to 2 minus f of x. Okay. Now, can you tell me what is f of x? 2 minus, what is the value of f of x I should take? Come on, quickly. F of x, what I should take? X minus 1 or x plus 3?
Yes. X minus 1.
Yes, x minus 1 we must take because x is less than 2. So x minus 1 you should take. Now you substitute. Substitution and finally you need to substitute. So 2 minus 1 is 1. So as x is tending to 2 from left hand side, f of x tends to 1. Okay, this is left hand limit. LHL. And RHL we take. What's this? Limit x tends to 2 plus f of x. First you should write this. And this is limit x tends to 2 plus, what is f of x?
X plus 3.
X plus 3.
X plus 3.
This is 5. So first of all, left hand limit is LHL is not equal to RHL. LHL is not equal to RHL. First thing you should understand this. So limit doesn't exist. Limit doesn't exist. So if limit doesn't exist, so discontinuous, automatically discontinuous. Discontinuous x equal to 2. Got it or not? And I'm not checking this f of 2, so I'm not checking. If okay, now let's take f of 2. Before that, I didn't check. First, I have to check whether LHL equal to RHL or not. It's not. LHL is not equal to RHL. So limit doesn't exist. So straight away, this is not continuous. So discontinuous, not continuous at x equal to. That is discontinuous at x equal to. So now, if I check f of 2, what is f of 2? F of 2 is the same, x plus 3 is 2 plus 3. So 5. So you know what you can say? Here you can say it is right continuous. See, one thing is, if at all LHL equal to f of a, then f is, left continuous. This is just definition, continuous. And if at all RHL equal to f of a, then f is right continuous. The only terminology, you should understand this. Even if LHL is not equal to RHL, but LHL is equal to f of a, then it is left continuous. RHL equal to f of a, then is right continuous. You understand? See, for example, LHL equal to RHL. I know. If LHL equal to RHL and LHL is f of a, RHL is f of a, both are also equal. Na? But what I am saying, only if LHL equal to f of a, then f is left continuous. And if RHL equal to f of a, what does it mean? LHL is not equal to RHL. This is the case I am discussing. Understand that. Okay, if LHL is not equal to RHL, in that case I am saying that if LHL is equal to f of a, then left continuous, RHL equal to f of a, it's right continuous. And if LHL equal to RHL equal to f of a, then left and right, both right, both left continuous and right continuous, complete continuous. Hope you got this point.
Yes, sir.
Yes, sir.
Okay, so this you saw, this continuous. Okay, but in this first point I checked. So second, now step 2. What I'm going to do is I'm going to check now. See here, at x equal to I checked. See here, now at x equal to 2 I checked. But what about now I'm checking at x equal to a, where a belongs to minus infinity to 2. Can you understand this point? I am checking at every point in the interval minus infinity to 2. At 2 I checked. At 2 it is discontinuous. Now what I am doing, I am checking at x equal to a, where a is any point. A का मतलब a भी हो सकता, -1 भी हो सकता, -2. You understand? 1 also. You got the point? 2.2 also. It's it's 1.3 also. Everywhere, x can be any real number in the interval minus infinity to 2. Okay, here what will happen? Left hand limit. You know what is left hand limit? Limit extends to a, f of x. What is that? Tell me. Left hand limit is what? You tell me.
X plus 3.
Oh.
No, x minus 1, sorry.
Yeah. X minus 1, you see here, because x, a is what? It's any number less than 2. It can be 0, -1, -2, 1.3, 1.9999999. It can be 1.999 also. Any number less than 2. So left hand limit is, limit extends to a minus. I'll write f of x to x minus 1. X minus 1. X is less than 1 for sure. All right. So x minus 1. So a minus 1 ho gaya. So right hand limit is also same. Limit extends to a plus. Approaching a from right hand side. But this is also, x minus 1, because a is less than 2. Any doubt here? A is less than 2. Any doubt? Limit extends to a plus, so we can write directly, no? So a minus 1. This right hand limit is, and of course, this f of a. Yes or no? Left hand limit is a minus 1, right hand limit is a minus 1, f of a also a minus 1. Why? Because a is less than 2. So therefore, what you can say? F of x is continuous in the interval minus infinity to 2. Are you clear in this? With this? Are you clear in this?
Yes, sir.
Vishta, are you clear?
So can you go back to the right hand rule part? Because if it's a plus, then how are we again taking?
Exactly. Yeah, you get doubt. What is that? A plus. So here is important, very important point you have. So you may say.
So that's because it belongs to the.
Exactly.
So that's because it's still part of minus infinity to 2, right?
Exactly. That's true. But here some hidden point is there. You may think, see, ये तो मान लेते हैं कि 1.99999. So like that, it's very, very close to 2. If I take it's very close to 2, what happens? Limit extends to a plus 1.99999. है ना? A plus. Yeah, f of x, this is f of x now. So can this be, so here is a doubt, can this 1.999 plus, it is, can this be, yeah, so can this be 2? Can this be 2? That is what is important here. That's what is important. Actually, 1.999 plus, so that means what? It is approaching 1.9999 from right hand side. So we will to 1.9999 from right hand side. Right hand side is approaching. So here is your 2. Let's say here is 2. Sir, it can be 2 also, no? You may say. That is a doubt here. That's a doubt here. But it is so close, so close, so close, so close. It is very, 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 very close. Approaching means, only thing is that, only thing you can say, it's not equal to 1.9999. That's all you can say. But it is so close, so close, so close. It already crossed 2. You understand this point, you should understand. You can't say it's x equal to 2, you can't say. But only you can say is what, x is not equal to 1.9999. It is not equal to this, but it is tending to this. That is so close. You understand my point? Rishita, you understand?
Yes, sir. Yes, sir.
X equal to 2. X equal to 2, you can't say. X equal to, for that matter, no, then we can say x equal to 3 also you can say, no. So it will not, then limit will not have a meaning. We understand it is so close, very, very close. Only thing is that, that's why I told when I discussed x equal to 2, okay, at 2, when we discussed at x equal to 2, I told that it is not equal to 2. At x equal to, it's not equal to, that's all we can say, but x value we don't understand how close it is to 2, but it's very, very close. That's what we should take, approaching means. Okay, anyway, so that's the reason I told you here that here also it is still less than 2. That's what we should understand. That's the meaning of limit actually. Okay, are
Yes,
you
sir.
clear with this?
Okay.
Yeah. Yes. So now similarly, when x equal to, see like this. Okay. So in this interval, minus infinity to 2, it is continuous, I know. Continuous. So here also, because it's polynomial, linear polynomial, or linear expression, linear polynomial, linear expression, and x plus 3, Hana. So so now close 2 to infinity. Also, it is continuous. But x equal to 2, at x equal to 2 only it is discontinuous. So therefore, same thing, same proof you can give. Whatever you are writing here, that's also step 3. In step 3, what you can write? We are checking at x equal to a, where a belongs to 2 to infinity. 2 to infinity. Oh no. Open 2 to infinity. Hannah, 2 already, at 2 we already checked. So open 2 to infinity. You can check at every point from 2 to infinity. So it is continuous again. Only at x equal to it is discontinuous. This point you should understand. Is that okay?
Yes, sir.
Okay, all right. So now let's go. And here I will show you now x plus 3, x minus 1. So I'll show its graph. So this is what is f of x. That is x minus 1. I'll write like this now. If x is less than x plus 3, if x is greater than 2. Let's draw its graph. Just show you graph so that you can understand better. So x is less than 2. So let's take x equal to is here, and less than 2 means here. Okay, till 2, x minus 1. So y equal to x minus 1, like this. You have to check y equal to x minus 1. You have to check, and you see here its slope is 1. Slope is mx. See, y equal to mx plus c. Slope and minus 1 is its y-intercept is minus 1. Slope is 45 degrees. 45 degrees means it has to go like this. 45 degrees means like this, it has to go. This is 45 degrees. It has to go here like this. Okay, so therefore I've drawn this, but what I do is, but you know what? Clear only I can draw. Why? Because there is a reason for that. When x is less than 2, at 2, it is not x minus 1. This graph is only when, this graph is there only when x is less than 2.
Less than 2.
X is less
Yes,
than
sir.
2. So x is less than 2. At 1, it is 0. At 0, it's minus 1. At minus 1, it is minus 2. At minus 1, it's minus 2. At minus 2, it is minus 3. Like this. But when at x equal to 2, at x equal to 2, what? So this is 1, 2, 3, 4, 5. At x equal to 2, you know what? At x equal to 2, it's 5. And x plus 3, what is the graph of x plus 3? Like this. X plus 3 is exactly like this. This y-intercept is like this. Like this. Graph is like this. Like this. But we should not draw this part. You should not draw. Why? You have to start from here. This part you should draw. Though y equal to x plus 3 is, y equal to x plus 3 is this. This is the graph. Y equal to x plus 3 is the graph. This one. But x is less than 2. X is greater than 2. From here, x equal to 2, this one. X equal to 3, this one. X equal to 4, this one. Like this. You have to draw this. And this is not required. This is not there. This is not. That is there. You understand?
Yes, sir. Got it.
So now you see, that's what we discussed. When x is less than 2, this is the graph. Therefore, it is continuous. At x equal to 2, at x equal to 2, you are able to see discontinuous. Till 2, it is see continuous, 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 continuous. Till 2, it is continuous. At 2, it is discontinuous because you have to lift the pen up and you have to go here and you have to start from here. Yes or no? At x equal to, and at x equal. So if you take at x value more than 2, it is continuous. Till infinity is continuous. You understand?
Yes, sir.
What is I understood?
Yes, sir. Yes, sir.
It is. It's so simple. It looks like so simple. Why we did so much explanation, but it looks like very simple. Yeah, because we have taken simple example. That's the reason. It is simple. Of course, here the point is it is at x equal to 2, limit doesn't exist also. Okay, anyway, now I'll show you one thing. I'll show you now. Let's take another example. Now discuss, just simply discuss continuity of f of x equal to 1 by x minus 5. Okay, just we need to discuss this continuity of the function at x equal to, continuity of the function f of x equal to 1 by x minus 5. Just we need to discuss this. What can you say about this? Whatever.
So the domain is
good.
all real
First,
numbers except 5.
yes, first thing you should understand domain is all real numbers but not 5. Yes, good. So here itself we can write x is not equal to 5. Good.
Yes, sir.
That's good. So first observation is that. So you know what? What is the meaning of the domain? What is the meaning of the domain? X value is simply X is not equal to 5. That's what is the. So X value can be any real number, but not 5. That means what? When X value is not equal to 5, X value is not 5, then obviously, so there is no graph, no curve at all. X 5, X is not taking